Wildcats. Today we're looking at journal page 22, solve systems of inequalities. Steps to graph systems of inequalities. Step 1, put equations in slope-intercept form. When you multiply or divide the inequality by a negative number, the inequality symbol flips. Step 2, y is less than or y is greater than is a dashed line. Y is less than or equal to or y is greater than or equal to is a solid line. Step 3, shade. Step 4, the solution is the overlapping region. If the regions do not overlap, then there is no solution. Question to think about is, when will there be an infinite solution to a system of inequalities? You would update your notes. Okay, now your notes are updated. Let's take a look at the examples. All right, example 1, sketch the solution to each system of inequalities. Okay, so first off, let's look at the first inequality. So y greater than 4x minus 4. Okay, and let me use a pen here so you can see the difference between the pencil and the, okay. All right. Now, the number in front of x is a slope, and slope is always a fraction because it's rise over run. So we need to divide this by 1. Okay. So to graph this, we now have it in slope-intercept form. We're going to start with the intercept. So we're going to put a point at -4. Okay. And then this tells us we go up 4 to the right 1. So up 1, 2, 3, 4 to the right 1. Up 1, 2, 3, 4 to the right 1. Now there's no line underneath, so it's a dashed line. Okay. Now it's greater than, so we shade above. Okay. Now let's take a look at the next inequality. So y greater than or equal to negative. I'm going to go ahead and put a 1x minus 3. And again, remember, we're going to divide by 1 because that's slope. Okay. So we start at -3. And here, this tells us we go down 1 to the right 1. So down 1 to the right 1. Down 1 to the right 1. But we know that -1 divided by 1 is equal to 1 divided by -1. So this goes down 1 to the right 1. This goes up 1 to the left 1. So up 1 to the left 1. 1 to the left 1, up 1 to the left 1, up 1 to the left 1, up 1 to the left 1. Now, there's a line underneath, so it's a solid line. Okay, and it's greater than as well, so we shade above. Now, the cool thing about using highlighters is the solution will be the overlapping region, and you can see the color change. Okay, so the solution is this region right here in the green, where they overlap. Okay, so if you haven't already, I'm using a yellow highlighter and a blue highlighter. Okay, those are what I recommend best. Will give you the best color change. Okay, all right, let's take a look at example 2. Okay, so we need to solve each inequality for y to graph it. So here we need to subtract 1x from both sides. So then you get y greater than 5 minus 1x divided by 1. Okay? So here we're going to start at 5. And we go down 1 to the right one. 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 There's no line in these, so it's a dashed line. Now it's greater than, so we shade above. Okay, now let's take a look at next. So we have x minus y less than negative 3. Okay, so we're going to subtract 1x from both sides. Get negative y less than negative 3 minus 1x. Now you're going to divide negative 1 by everything. So that's y less than, that becomes a positive 3 plus 1x divided by 1. So we start at 3. Okay, and we go up 1 to the right one, up 1 to the right one. There's no line underneath, so it's a dashed line. Oh, but wait a second. Made a mistake, and I'm kind of glad I made a mistake, so I know that because this is a common mistake students make. Okay, when you divide by a negative, this inequality flips. So you have to be careful to look out for that. Okay. So now that changes. Well, first it's still dashed, so let's do that. Okay. It's greater than, so now we shade above. And again, we're looking for the overlapping region, and you'll see that it will change colors. So there's your solution in that region right there. Okay, so finish up example 1, example 2. All right, example 3. Okay, so we're going to subtract 2x from both sides. We have negative 3y less than or equal to negative 6 minus 2x. We're going to divide negative 3 by both sides. Now remember, when you do that, the inequality flips. So we have y greater than or equal to negative 6 divided by negative 3 is a positive 2. And then negative 2 divided by negative 3 is a positive 2x divided by 3. Okay, so we started the y-intercept, so that's 2. And this tells us we go up 2 to the right, 1, 2, 3. Now we know that 2/3, and I guess I'll write it right here, 2/3 is equivalent to negative 2 divided by negative 3. So we can go down to the left, 1, 2, 3. And now there's a line in these, so it's a solid line. And since it's greater than, we shade above. Okay. Now let's look at the equality here. So 4x minus 6y greater than 6. So we're going to subtract 4x from both sides. We get negative 6y greater than 6 minus 4x. Now we're going to divide everything by negative. So that means inequality flips. So this becomes less than. So y is less than. 6 divided by negative 6 is negative 1. Negative 4 divided by negative 6 becomes a positive 4 6x. Okay, so we start at negative 1. And we go up 1, 2, 3, 4, I'm sorry, up 1, 2, 3, 4. Sorry, 1, 2, 3, 4, 5, 6 is right there. Now, 4, 6 reduces to be, we can do that. Let's do it on a separate, right here. 4, 6 reduces to be 2/3. Okay? So, we can actually from here go up 2 to the right, 1, 2, 3. Up 2 to the right, 1, 2, 3. Now, 2/3 is equivalent to negative 2 divided by negative 3. So we can also go down 2 to the left, 1, 2, 3. Now, there's no line in, so it's a dashed line. Since it's less than, we're shading below. Okay, now you see here that they do not overlap, so we would say that this is no solution. Okay, all right, finish up example 3. All right, let's take a look at example 4. Now, x is greater than 5 is a vertical line at 5. So you have vertical line here. Oh, wait, I shouldn't put a dot. Sorry. That's a dashed line at 5. So one, draw a dashed line. And it's greater than, so we shade to the right. Now, this should say y is greater than or equal to 1/2 x minus 4. Okay. So this, we start at negative 4, and we go up 1 to the right 2, up 1 to the right 2. It's a solid line. Okay. And then it's greater than, so we shade above. And you can see here that the overlapping region changes colors, and that's your solution. Okay, go ahead and finish up example 4. All right, now, when you move past 2 equations, you're going to stop using highlighters because it's just not practical. So you're just going to use a pencil, okay? Now, y greater than x, well, that's just the parent function 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, negative 1, negative 1, negative 2, negative 2, negative 3, negative 4, negative 5, negative 5, okay? There's a line underneath, so it's a solid line. Now, it's greater than, so we shade above, but I'm going to shade light, okay? shade light on the first shade. Okay. Now, let's take a look at this. So we have y less than or equal to, and put 1 in front of the x, and divide that by 1 plus 5. Okay. So we start at 5. Now, it doesn't look like we can go up, but remember, 1 divided by 1 is equivalent to negative 1 divided by negative 1. Okay? So this says go up 1 to the right 1. This will say go down 1 to the left 1. So we can go down 1 to the left 1, 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 down 1 to the left 1. It's a solid line. Now it's less than, so we shade above. Now this region is getting darker, okay? Because it overlaps. This region doesn't, so we just shade light, okay? But so far, this region has gotten darker because it overlaps, okay? Now, y is less than 5. That's a horizontal line at 5. And it's less than, so we're shading below. Now, this overlapping region gets darker, but this region is overlapped again, so it gets even darker. And then this region gets a little darker because it overlaps. But so far, this is the reason it keeps getting darker, because it's overlapping. Okay? Now let's look at the last one. X is greater than or equal to negative 2. So that's a vertical line at negative 2. And it's greater than, so we shade to the right. Now this region got a little darker. Right? Let's see. Vertical line right there. And that got a little darker, but this is the region that got the darkest. This region right here. Now technically this region gets slightly darker, but this is the region that overlapped each region. So this is your solution. Okay. All right, so go ahead and finish up example 5. All right, let's take a look at example 6. Okay. So y is less than x. That's again the parent function. It's a solid line. Now, it's less than, so this region we shade. Again, we're doing it light. And what you might do is just to get all the shading in, is go past the line, but then go back and erase. Okay. Now, y is greater than or equal to 0. So that's a horizontal line at 0. So this region gets darker. Okay. This region is shaded, but it doesn't get darker because it didn't overlap anything. Okay. Now, so y is less than or equal to negative 1x plus 2, but remember that's divided by 1. Okay. So we start at 2. And we go down 1 to the right 1, 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 down 1 to the right 1. It's a solid line. and it's less than, so we shade. This region gets slightly darker. This region gets shaded. But this region is overlapping, so it gets the darkest, and that gets slightly darker. So you can see your solution is that region right there. Okay? So if you would finish up example 6 and start working your assignment and have a wonderful Wildcat day.